we have seen, and what is complexation, that also we have completed. So can you tell me one example that how solubility is increased by the help of complexation? How solubility is increased by the help of complexation?
Sir, caffeine increases the solubility of para-amino benzoic acid or PABA in water by complexation.
Yeah, very good. Kapha and pava, caffeine and pava complex. Okay,
Yes, sir.
so we can increase the solubility of pava by the help of complexation with caffeine. Okay. Then how to decrease toxicity by the help of complexation? কোশ্চেনটা বুঝতে পারলে?
Hello, sir.
হ্যাঁ, বলো।
Sir, toxicity or ulcerogenic effect of iodomethacin is decreased with the help of cyclodextrin.
Okay. Okay. Or any other applications? For example, how physical state of any compound that can be increased by the help of complexation? How physical state can be improved by the help of this complexation?
And the nitroglycerin, the physical state of nitroglycerin can be controlled by beta cyclodextrin.
Then what will happen?
So it will be more stable.
It will be more explosion proof. 15.6% nitroglycerin. If we prepare complex with beta cyclodextrin, then it will be explosion proof. And this is one type of complex that we can say that is a type of inclusion complex. Now, what is inclusion complex, that we will study later. So various application that we have completed last class, and what is ligand, that also we have completed, and what type of intermolecular force that are present in the formations of complex, what type of intermolecular force that are responsible for formation of complex.
The hydrogen bonds are then
The van der Waals force, then coordinate covalence force.
yes, then ion dipole in dipole and
Dipole force bond.
Very good. So সবার মনে আছে দেখছি মোটামুটি। So today we will study about the classification of complex. Very much important. You have to remember this. See that classification of complex. The complex are broadly classified into 3 groups. First one is metal complex. Second one, organic molecular complex. And third one, inclusion or occlusion complex. Okay, first one is metal complex, second one organic molecular complex, and third one inclusion complex. Now, metal complex that are also classified into 4 groups. First one is inorganic type, second one chelate, third one olefin type, and fourth one aromatic type. Okay, so metal complex that are classified into 4 groups: inorganic type, chelate type, olefin type, and aromatic type. Okay, next, second one, organic molecular complex that are also classified into 4 subgroup. First one is Cohen-Hindroth type, second one caffeine complex, already all of you know caffeine pava complex, third one picric acid complex, and fourth one polymer complex or polymeric complex. Okay, Cohen-Hindroth, caffeine, picric acid, and polymeric complex. That is the subclassifications of organic molecular complex. And third one, that is inclusion complex, that are also subclassified into 4 groups: clathrate, channel type, layer type, and fourth one, monomolecular inclusion type. Okay, clathrate complex, channel type, layer type, and monomolecular inclusion type. This is the classification of complex. Now here, one by one, we will discuss about that. So first one is metal complex. Metal complex, from its name itself, what we can say that one central atom will be there, and that will be one metal. In this type, metal ion constitute the central atom. Central atom means that is substrate, and it will interact. That means metal ion that will interact with a base. Base means ligand. So central atom, that is substrate, and it will interact with a base, that is known as ligand. And here one important thing is that electron pair donor, the ligand that will act as a electron pair donor. This type of interaction which leads to the formation of coordination bond between the species. Coordination bond. See that classification here where I have written that metal complex or coordination complex. Metal complex or coordination complex. When I have to typing a mistake আছে, complex এখানে আসবে. Metal complex or coordination complex. So why it is called coordination complex? Because this type of interaction which leads to the formation of coordination bond. That's why it is also called coordination complex. Now, here one scientist that is known as Werner. Scientist Werner, he has described a number of rules by which some of the deviation from the classical theory of valency that can be rationalized. He told that there are 2 types of valencies. One is primary valencies and second one is secondary valency. Primary valency, that is known as ionic, and secondary, that is known as coordinate. Okay, 2 types of valencies are there: primary or ionic, secondary or coordinate. Now, in cases of metal complex, it contains one central atom, and that is a metal. Metal atom or ion which is bonded to one or more ligand. Okay? And after bonding, it can be neutral or positively charged, or it may be negatively charged. Coordination number. Coordination number, what is that? For each central atom or ion, there is a fixed number of non-ionic valency. Okay? For each central atom or ion, there is a fixed number of non-ionic valency. That non-ionic valency number, that is known as coordination number. Now, the coordinated atoms or groups, they will occupy the first sphere or coordination sphere. Other atom, they are said to be in second sphere or ionization sphere. Okay. Now, what is about this coordination sphere or ionization sphere? We can describe it by the help of one example. See that here I have written COClNH3(5)Cl2. Okay. So the non-ionic valency that are directed towards definite position in the space. One chapter is there in chemistry that is known as stereochemistry. Stereochemistry. So all these non-ionic valencies that are directed toward definite position in the space, that is known as stereoisomerization. Okay, stereoisomerization. So what I told, metal, one central atom will be there, and that will be metal. That metal ion that will act as a substrate, or that is also known as central atom. Then it will bind with one ligand. It will donate the electron pair by which complex will form. And when substrate and ligand that will bind to form a complex, this formations means what type of bond that is responsible for that? Coordination bond that is responsible for this type of metal complex. So metal or substrate or central atom, then base that is known as ligand, electron pair donor. This is important, donor. Then by the help of that electron pair, that metal with central atom that will bind with the ligand, and it will form, this complex will form by the help of coordination bond. Here in this case, the ligand provides only one site for binding with metal. The ligand provides only one site. So when any ligand, it provides only one site for binding. So that is known as, last class we have seen, if one binding site is there. Huh?
Unidentate. Unidentate. Monodentate.
Unidentate or monodentate. So in this case, one example I have given, see that COCl whole 5 Cl2. So here only one binding site is there. That's why that ligand that is unidentate. In this case, metal ion and ligand, they will bonded to each other by covalent bond, or that is also known as electrostatic bond. So electrostatic or covalent bond. MCQ তে এগুলোই আসবে কিন্তু, that in cases of inorganic type complex, metal and ligand bonded to each other by hydrogen bonding, covalent bonding, coordinate bonding, or dipole-dipole bonding. Okay, so true answer is covalent bonding. Here, this complex consists of a metal ion. What type of metal that may be? That may be cobalt, iron, copper, nickel, zinc. All these are the example of central atom. That central atom that will linked with one or more counter ion or molecule to form a complex. Okay, that are linked with one or more counter ion or molecules to form a complex. Now, the ions or molecules, for example, chlorine, ammonia, NH3, water, bromine, iodine. Okay, all these are directly bound to the metal, which are called ligand. Now, the interaction between the central atom, that means metal, and the ligand, that can be represented by the help of Lewis acid-base theory. Okay, Lewis acid-base theory, chemistry. The metal ion, that is also known as Lewis acid, that combined with a ligand, that means Lewis base, by accepting a pair of electron from the ligand to form a coordinate covalent. Now here example I have given here, see that COCl whole 5 Cl2. With the help of this example, we can describe the metal complex or organic complex, sorry, inorganic complex. Now in this case, see that two types of valencies are there. এটা আমি describe করছি একটু, তাহলে তোমরা আরো পরিষ্কার হবে. There are two types of valencies: primary, that means ionic, and secondary, that is coordinate. Now same type of anion, radical, or molecules that may be held by either or both type of valencies. What I told, same type of anion, radical, or molecule that may be held by either or both type of valencies, that means ionic or coordinate. Now for each central atom or ion, there is a fixed number of non-ionic valencies. Now, non-ionic valencies means that is coordination number. Now the coordinated atoms or groups occupy the first sphere or coordination sphere. Here coordination sphere means this portion. This portion is known as coordination sphere. Central atom, what is central atom here in this case? Cobalt, CO. This is central atom. The first sphere, that is COCl NH3 5. This is coordination sphere. Here, what is ligand? ClNH3 5. This is ligand, which is unidentate. And another one sphere is there, that is ionization sphere, that is Cl2. Okay, so 4 things are there. Central atom, that is cobalt, ligand, this portion, that is unidentate, and central atom and ligand, both portion. This portion is known as coordination sphere, and rest of that is known as ionization sphere. Okay, so for each central atom or ion, there is a fixed coordination number. The coordinated atoms or groups, they will occupy the first sphere. First sphere means coordination sphere. And other atom, in this case, other atom means that is chlorine. That atoms are said to be in the second sphere, that is also known as ionization sphere. If clear, so one central atom is there that will bind with the ligand, which is unidentate. This portion is known as first sphere or coordination sphere, and other atom that are said to be in ionization sphere or second sphere. Now, the non-ionic valencies that are directly towards definite position in the space. The non-ionic valencies are directed towards definite positions in the space. That's why that is also known as stereoisomerization. Okay. Now, in solution, especially in this case, in solution, this compound, it will ionize, and if this compound is ionized in the solution, then what type of ion that will form? If this compound, that is ionization in solution, for example sodium chloride, if it is ionized, then what type of ions that will form? Na plus or Cl minus, right? Now in this case, if it is ionized, then what type of ion that will form?
The coordination sphere ta cation hobe.
Sir, positive. Positive.
Hello?
Yes.
Sir, cation hobe.
ঠিক বলেছো। That means COCl NH3 5 plus or Cl minus. Am I right? So in solution, this compound ionizes to form COCl NH3 5 plus and 2Cl minus. Okay. Now, this chloride ion in the coordinated sphere, that cannot be precipitated by silver nitrate. What I told? Chlorine আছে না, COCl. So this chlorine, আমরা ক্লোরিনের একটা টেস্ট আছে, দেখবে সিলভার নাইট্রেট দিলে কি হয়, হোয়াইট কালার প্রেসিপিটেট পড়ে, তাই তো? হোয়াইট কালার প্রেসিপিটেট পড়ে। তো তাহলে দেখো, এই যে হোয়াইট কালার প্রেসিপিটেটটা কিসের? সিলভার নাইট্রেটের একটা টেস্ট আছে, কেমিস্ট্রিতে করোনি তোমরা? কেমিস্ট্রিতেও পড়েছো তোমরা। সিলভার নাইট্রেট যেই দিলাম, কি হলো? হোয়াইট কালারের প্রেসিপিটেট হলো। এই হোয়াইট কালার প্রেসিপিটেটটা কিসের? Silver chloride. Yes, AgCl. So in this case, this chloride ion, which is present in coordination sphere, that cannot be precipitated by silver nitrate. Now, groups like chlorine, Cl group, NH3 group, in the coordination, chlorine ache, NH3 ache. So all these groups in the coordination sphere, that are called ligand. So what is the role of this ligand? They will always donate electron to the central atom. What I told? What is the role of this ligand? This chlorine, NH3, all these groups which are present in coordination sphere, they are called ligand. They always donate electron to the central atom. Okay. Now, the type of bonding in this case between the metal and ligand, the type of bonding present in this case, the central atom cobalt and ligand, that is covalent bond. Okay, তাহলে প্রথম থেকে আরেকবার বলি। So in this case, if this compound is added in any solution, so then this compound ionization to form COCl NH3 whole 5 2 plus, that means cation, and 2Cl minus. The chloride ion which is present in the coordination sphere that cannot be precipitated by silver nitrate. Now the group like chlorine or NH3 which is present into the coordination sphere that are called ligand. What is the role of that ligand? They always donate electron to the central atom. In this case, the central atom is cobalt. Now the type of bonding present in between cobalt and ligand, in this case, that is covalent bond. Okay. Now coordination number আমি বললাম না একটা, আচ্ছা এটা আমি অলরেডি বলে দিয়েছি। হ্যাঁ, now what is coordination number? The coordination number of central atom, that is the maximum number of atoms or groups that can combine with the central atom in the coordination sphere. What I told? What is coordination number? The coordination number of central atom, that is the maximum number of atoms or groups that can combine with the central atom in the coordination sphere. For cobalt, especially in this case, for cobalt, what is the coordination number? In this case, the coordination number of cobalt is 6. Since it complexed with 6 NH3 group. From this example, we can clearly see that the coordination number in cases of cobalt, that is 6. So we can say that it complexed with 6 ammonia group. Now the concept of hybridization, hybridization technique পড়েছো না কেমিস্ট্রিতে? So the concept of hybridization technique that can be extended to understand the formation of coordination bond, especially in this type. Okay. Now, so by the help of this example, we can describe or we can easily understand that how metal complex that will form coordination bond with different types of ions. So ligand donate a pair of electron for the formations of coordination bond in this case. Now, whatever electron that will donated by that ligand, that electron pair that will be accepted by metal ion. That will be accepted by metal ion. Now, in metals, all the orbital, for example, S, P, D, that are to be considered to account the complexation. মনে আছে কি অরবিটাল থাকে? S orbital, P orbital, D orbital. Okay, so in this case, the coordination number of cobalt is how much? 6. So the trivalent cobalt ion that has given electronic configuration in the ground state. In cases of EDTA, ethylene diamine tetraacetic acid, it has 6 points of attachment, so that are known as hexadentate. The example টা দিলে আরেকটু পরিষ্কারভাবে তোমরা বুঝতে পারবে। See that? Especially in this case, or in this case, see that this is 2, 4. Here also 4. This is octahedral. So linear, tetrahedral, square planar, octahedral. So coordination number, what is that? It will determine the geometry of the complex. So coordination number, that is the maximum number of atom or groups that can combine with the central atom in the coordinated sphere. This coordination number determines the geometry of the complex. That means complex will be linear, or it will be tetrahedral, or it will be square planar or octahedral. That completely depends on the coordination number. Now, already I told the scientist Werner, he has described the formation of complex, especially inorganic complex with metal. Now, cobalt that seems to make use of their 3d, 4s and 4p orbital. This one. আগে এটা বলে দিই তারপরে এটা আসবো, ঠিক আছে? Compound ionizes to form COCl NH3 whole 5 plus 2 and 2Cl minus. Okay? That central coordinate do not precipitate with silver nitrate, already I told. Substrate and ligand, they are bonded with coordination bond. Coordination number, that is the maximum number of atoms and groups that combine with central atom in coordinated sphere. In this case, the coordination number for cobalt is 6. Now see that cobalt seems to make use of their 3d, 4s and 4p orbital in forming hybrid. But this type is different from the classical concept of hybridizations. If we see in the classical theory of hybridization, the electron pair that is promoted to unfilled orbital, right? The electron pair that is promoted to unfilled orbital. So this half-filled orbital further involved in the chemical bonding. Especially in this case, see that unfilled orbital 1, 2, 3, 4, 5, 6. In cases of 4b orbital, 3 are there. In cases of 4s, 1, and in cases of 3d orbital, 2. So this half-filled orbital that will involve in the chemical bonding. In complexation, the electron in a half-filled orbital that will shift to other orbital in order to fill them as electron pair. So this create completely vacant orbital in the metal electronic configurations. That electronic configurations of that metal ion which is leads to fill 3d level. Okay. Now, if ligand donate its electron pair to this vacant orbital of the metal ion, this results in the formations of complex. So we can say that D2 or sp3 or octahedral structure is predicted as the structure in the complex using this technique. So Werner proved that cobalt complex are octahedral. Why it is octahedral? Because 6 are there. Because the structure of that cobalt, coordination number of cobalt, that is 6. There are two types of valencies, ionic and coordination. Same type of anion, radical or molecule that may be held by any one or both type of valencies. Every central atom has fixed number of non-ionic valencies, that is coordination number. In cases of cobalt, that is 6. The coordination atoms, they will occupy the first sphere or coordination sphere, this one, and other atoms occupy the second sphere or ionization sphere. So the non-neutral atom or ion, they may satisfy the non-ionic valencies. The non-ionic valencies are directed to specific positions into the space. Okay. So this is all about inorganic complex, inorganic metal complex. যদি এটা আসে এক্সামে তাহলে তোমরা এই এক্সাম্পলটা দিয়ে ডেসক্রাইব করবে। Okay, that COCl NH3 whole 5 Cl2, where substrate, that means cobalt, that is central atom, that is known as substrate, Cl NH3 whole 5, that is known as coordination sphere or first sphere, and rest of that is known as second sphere or ionization sphere. where chlorine is present, and the chlorine which is present in coordination sphere that cannot be precipitated by silver nitrate. Okay, and the bond present in between cobalt and coordination sphere, that means substrate and ligand. So the bond present in between that substrate and ligand, that is known as hello, শুনতে পাচ্ছ কথা? Hello,
Yes,
am I
sir.
audible, students? Okay,
Yes,
okay.
sir.
So what is chelate? Chelates are a group of metal ion complex in which a substance, that means ligand, provides two or more donor groups to combine with a metal ion. And in this case, ligand that may be didentate or tridentate or polydentate. Okay. In inorganic metal complex, the ligand provides only one site. Already we have seen. Whereas in chelate, one ligand provides more than one site for complexation. Okay, what I told? That chelates are a group of metal ion complex in which a substance, that means ligand, provide two or more donor groups to combine with a metal ion. In cases of inorganic metal complex, we have seen the ligand provides only one site for binding with the metal. Whereas in chelate, one ligand provides more than one site for complexation. Okay. So depending on the number of donor groups available for complexation, ligand are called bidentate or tridentate or polydentate. Bidentate means two groups, tridentate means three groups, or polydentate means more number of groups are there. So ethylene diamine tetraacetic acid, EDTA, it has 6 points of attachment to the metal ion. That's why it is known as hexadentate. Okay, that is known as hexadentate. So EDTA provides more points for binding. Now, diverse type of bonds such as ionic or primary covalent or coordinated bonds that are involved. These bonds that can be seen in calcium EDTA chelate. Now here, see that hexadentate ethylene diamine tetraacetic acid, it has a total number of 6 points for attachment of that metal ion. Here we have seen that 6 points of attachment: 1, 2, 3, 4, 5, and 6. This is a process in which property of metal that can be suppressed without removing it from the solution. That's why that is also known as sequestering process. So what is sequestering? That is a process in which the property of metal that can be suppressed without removing it from that solution. So what is sequestering agent? Sequestering agent, that means this is a ligand which forms a stable water soluble metal chelate. For example, hemoglobin, chlorophyll, all are known as sequestering agent. Okay, so calcium EDTA, that will bind with that calcium, so it will form a larger complex, and that is also known as calcium EDTA chelate. So chelation, that is the formation of two or more coordinated bonds between a multi-dentate ligand and a single central atom. And the bond in that chelate, that may be ionic type, that may be primary covalent or coordinate type. Okay, that is known as chelate. A substrate, sorry, a substrate, that means ligand containing two or more donor groups that may combine with a metal to form a special type of complex that is known as chelate. Example, EDTA. Two geometric forms of chelate are available. One is cis isomer and another one is trans isomer. Example, alcohol dehydrogenase enzyme, that is cis isomer. Okay. And trans isomer, example, vitamin B12 or hemiproteins. So chelates are naturally occurring, that is chlorophyll, hemoglobin or albumin. So that is all about chelate. Now applications of chelate. How chelates are useful in pharmaceutical science. See that first one, increasing solubility. Fruit juice and drug, for example, ascorbic acid, it will form a complex with iron and copper. So because of that, oxidative degradations will be there. And in this case, if you add EDTA, then it will form a stable chelate. So the oxidative degradations of fruit juice, that can be prevented by the help of formations of chelate with EDTA. And second one, purification of hard water, that can be also done by the help of chelation. See that hard water plus EDTA. So EDTA calcium precipitate, that will be completely separated out. So pure water that we will get. So for purifications of hard water, chelation technique that we can use to get pure water. Then drug analysis, sorry, spelling mistake. Drug analysis. Procainamide, and examples of drug that will form a complex with cupric ion 1:1 at pH 4 to 4.5, and it will form a complex that will be completely colored. So that can be detected by colorimetry. So by the help of colorimetry, we can analyze drug where that complex that will form, that will be completely colored complex. So because of that color, by the help of colorimetry, we can easily analyze any drug, for example, procainamide. Then chelation, that can be also used as an anticoagulant, blood plus EDTA, that EDTA or citrate or oxalate, it will prevent thrombin formations, so no clotting will be there. So that chelation technique, that can be also used as anticoagulant. Then that chelating agent that are used in water treatment program, softening of water, oxidative degradations of drug and citric acid into the fruit juice, that can be prevented by chelation with EDTA, or it can be used as anticoagulant, in vitro anticoagulant. যেমন ধরো এই যে ব্লাড কালেকশন করা হয় ব্লাড ডোনেট ক্যাম্প থেকে, তো সেখানে তারা সেই যে প্যাকেটের মধ্যে যেখানে ব্লাডটাকে ওরা কালেক্ট করে তার মধ্যে কি দেওয়া থাকে, অ্যান্টিকোয়াগুলেন্ট, আদারওয়াইজ কি হবে, কোয়াগুলেট করে যাবে। Detoxifications of poisonous metal agent, for example mercury, arsenic and lead, that can also be we can say that is applications of chelation technique. Or to remove color impurities from antibiotic preparations, chelation technique that can be used. Next, chelate complex of gadolinium that are often used as contrast agent in MRI scan. MRI, magnetic resonance imaging. So for MRI purpose, we can also use this technique, that is chelation. Chelate complex of gadolinium that can be used as a contrasting agent in cases of MRI scan. Then orenophine, that is another one examples of chelate complex of gold that is used in the treatment of rheumatoid arthritis. নিশ্চয়ই নাম শুনে থাকবে, আর্থারাইটিস, গাঁটে গাঁটে প্রচুর ব্যথা হবে। So in the treatment of rheumatoid arthritis, auranofin, that is example of chelating agent that can be used. Penicillamine, that form chelate complex with copper, which is used for the treatment of Wilson disease and cystinuria. So see that so many examples are there, so many applications of chelate are there. So penicillamine, it will form chelate complex with copper, which can be used for the treatment of Wilson disease and cystinuria. Then these metal chelate compounds that are common components of fertilizer to provide micronutrients to the plant. Okay? Metal chelate, that compounds are common components which can be used as a fertilizer to provide micronutrients to the plant. So all these are the various types of applications of chelate. Okay, so applications of chelate, examples of chelate, এগুলো ভালো করে মনে রাখার চেষ্টা করবেন। ওকে, সো আজকে আমি এই পর্যন্তই নেব, ঠিক আছে? আমি কারণ 11:30-তে তোমাদের একটা আজকে ওয়েবিনার আছে আমাদের কলেজে, দেখেছো তোমরা সবাই রেজিস্ট্রেশন করেছো?
Yes, sir.
হ্যাঁ, তো আমি এখন কলেজ যাব, তো সেই কারণে আজকে একটু তাড়াতাড়ি আমি ক্লাসটা কমপ্লিট করে দিলাম, ঠিক আছে? ওই জন্য 45 মিনিটস এর আমি শিডিউল করেছিলাম। তো আজকে তাহলে যে দুটো পড়ালাম সবার কাছে ক্লিয়ার, ইনঅর্গানিক কমপ্লেক্স আর চিলেট?
Yes, sir.
এটা তোমরা একবার ভালো করে পড়বে, পড়ার পর আমি পরের দিন ক্লাসে মানে মঙ্গলবার দিন আবার এটা যদি কারো মনে হয় যে ডাউট আছে আরেকবার আমি রিপিট করে দেবো, তোমরা ভালো করে পড়ে বোঝার চেষ্টা করবে। হোয়াট ইজ কোঅর্ডিনেশন স্ফিয়ার, এগুলো বললাম আমি, ঠিক আছে? হোয়াট ইজ দ্য মিনিং অফ আয়নাইজেশন স্ফিয়ার and how metal complex will form, what is the meaning of unidentate, bidentate, what is the meaning of substrate, what is the meaning of ligand, ঠিক আছে? এগুলো যত ভালোভাবে বুঝতে পারবে এক্সাম্পল গুলো মনে রাখতে পারবে। So applications of chelate and how chelate will form, examples of chelate and inorganic complex, এই দুটো জিনিস আজকে আমরা পড়লাম, and classification, ঠিক আছে? Remaining portions that we will continue in next class.
Okay, sir. Thank you.
ওকে, ঠিক আছে, তাহলে আমি এখানে কমপ্লিট করলাম সবার জন্য। কারো কোনো ডাউট থাকলে নেক্সট আমাকে ওগুলো কোশ্চেন গুলো জিজ্ঞেস করো, ঠিক আছে? আমি ডাউট ক্লিয়ার করে দেবো, আজকে একটু তাড়াতাড়ি কমপ্লিট করলাম। থ্যাংক ইউ অল।
Thank you, sir.